I'm about to help you save a ton of time solving this problem with two awesome tricks. And if you want to become a number ninja who quickly crushes these problems on your AP exam, be sure to smash that subscribe button. Let's get started. Tip number one, notice that this problem has both sine of x and cosine of x in the problem. And they relate to each other because when you integrate cosine of x, you get sine of x plus c. So instead of blindly using a slower method like integration by parts here, this allows you to use what's called a u-substitution. I have another video if you need a refresher, but if you found an even faster way, leave a comment below and tell me what you think. I know there are formulas you might learn in class that allow you to plug and chug away and get the solution even quicker, but my channel is about understanding. And so by sticking around, you're going to understand this so that you can solve it in case you don't remember some magic formula. But basically for the u substitution, what I'm going to do is I'm going to let u equal cosine of x plus pi, and then taking the derivative of both sides, you will get du equals negative sine of x dx. We got to fix this up a bit though, because in the original problem, we have sine of x dx at the top. So multiplying both sides by -1 will give us that on the right. But now on the left-hand side, you've introduced this -1 in front of du. And so when we plug back into the integral, you'll have -1 now in front of du all over the square root of u. But here's a little bit of a challenge. The original integral was for x equals 0 to x equals pi. But now we're working with u, so we can't use those values anymore. I'm going to use these placeholders here, ul and uh, where ul will represent the lower limit in terms of u, and h will represent the higher limit. When I plug in x equals 0, the original lower limit, this will give a new lower limit for u as cosine of 0 plus pi, which will be 1 plus pi. And repeating this by plugging in the original value of x for the upper limit, which was pi, you will end up with -1 plus pi here. Do you see a problem though? Think about it, pause the video, and let me know. Okay, so notice how in this case, what I am calling the higher limit, UH, is a value -1 plus pi, which is actually smaller than the lower limit 1 plus pi. But don't worry, there's a cool way to work with this. You can basically change the direction of integration here. Think visually, instead of going from left to right, right to left, vice versa on the Cartesian plane. What I want to do is I like working with a lower limit of integration actually being the smaller number. So I'm still going to use a smaller limit, which is UH in this case, -1 plus pi to 1 plus pi. But to correct the fact that I swapped the limits of integration, I basically just introduced this -1 term in front of the integral. And this method is just more conceptually easy to me. And so now you have a negative in front of the integral and a -1 in front of du. So just multiply those through and you'll simplify the expression to the integral of -1 plus pi to 1 plus pi of du over square root of u. Now, this is actually a simple polynomial integral in disguise, because whenever you see a square root like this, remember, it's just a power. You have the power of u to the -1/2, and you know the original thing you get when you integrate has a power that's 1 greater. In other words, -1/2 plus 1 is the same as -1/2 plus 2 over 2. So we know the original function you get after integration has a power of u raised to the 1/2. And then to correct the fact that what we started with had a 1 in front of u to the -1/2 means that integration here will produce a result that has a 2 in front. Now, the question for you is, say I'm on my AP exam and I've got 5 minutes left, and this is a definite integral problem. And now you have an expression in terms of u here from -1 plus pi to 1 plus pi, and I need to solve this. Should I go back to the original variable x? Think about it. Okay, so because you're not solving an indefinite integral where you have a final expression that needs to be in terms of x, because it's a definite integral here, our answer is simply a number. So why? Why go back to working with x? Just simply stick with u here, and that is your second time-saving tip I highly recommend. And when you want to get the results here, if you don't remember how to do this for a definite integral, don't worry, I've got the perfect video for you.